Hello, everyone. Welcome to our talk. Today, Garrett and I are going to be talking about abusing Active Directory certificate services, and you'll see why we come to call it Certified Priv as a Service. So a little bit about us. My name is Zach Stein. I'm a senior security consultant here on Optiv's Attack and Pen team. I hold a few industry certifications, including the OSCP and the OSCE.
And my name is Garrett Foster. I'm also a senior security consultant at Optiv, and I've also got my OSCP and I've got my PTX V2.
So going into a little bit of background, we're going to start with what is Active Directory certificate services. So a brief intro, in June 2021, Will Schroeder and Lee Christensen over on the SpectreOps team released a white paper called Certified Pre-Owned. And this paper outlined multiple privilege escalation opportunities within Active Directory certificate services, also known as ADCS. So for the last year, we've seen these in our own engagements and in our own attack scenarios. So today, we're going to be spreading the word on these vulnerabilities, looking at the most commonly observed cases that we've seen, breaking down how the misconfigurations work, and then reviewing remediation efforts. So what is ADCS? ADCS is Microsoft's public key infrastructure that is integrated right into Active Directory. So it is not installed by default, but it's very commonly seen in enterprise environments. In every enterprise environment we have been in on our engagements, there has been some form of Active Directory certificate services installed. So overall, it's a pretty simple setup. It consists of one server role, and that's called the Enterprise Certificate Authority. We'll be referring to those as CAs for the remainder of this presentation. And this is the actual server that's responsible for issuing all the certificates. These can be standalone, or they can be integrated right into the domain controller. So a little bit about how you obtain a certificate. This is a photo from the white paper. So the first step is the client. So when a client wants to request a certificate, they generate a public and private key pair, and then they send what's called a certificate request to the CA. So this is the CSR, and this is going to contain information such as the template name, the subject, EKUs, and other fields that are needed for the functionality requested by the client. So once that CSR gets to the CA server, it's going to check a few things. It's going to see, does the certificate exist? Is the user allowed to request a certificate? Are the fields they're asking for valid? And do checks in that manner. So if everything checks out, the CA is going to sign that certificate with its private key and send it back to the client. The client is then it's going to be stored in their Windows certificate store, and then they can perform actions allowed by the certificate. So there's a few of these, and we'll be getting into these in a little bit. So there's a few fields that we're mostly concerned with on these certificates. The first one being subject alternative names. So the textbook definition is an extension that allows additional subjects to be bound to a certificate. So an example to make it a little easier is if you have certificates for HTTPS, instead of having a different certificate template for every single subdomain, for example, here we can have the main name optiv.com and the subject alternative name of www.optiv.com or email.optiv.com. So you can specify things like subdomains in there, so you only have to use the one certificate. The second field that we're most concerned about is extended key usages. These are also called enhanced key usages, but more simply, we're just going to refer to them as EKUs. So EKUs are the actual security descriptor that describe how a certificate can be used. So if you see here on the right, this is the default user template that comes built into ADCS. And we can see that these EKUs are for encrypting the file system, securing email, and client authentication. So all these, with the certificate, all of these actions can be performed. So after that brief introduction, that's really all the basis we need to start exploring what these misconfigurations are. So we'll start diving into those now. So there's several prerequisites that almost all ADCS misconfigurations have in common. So the first one is that the enterprise CA itself allows for low privilege users to enroll in certificates. This is a default setting on the CA when ADCS is enabled. The second one is the certificate itself does not require manager approval. So in ADCS, there is a role for managers. And when a certificate is requested and the template requires manager approval, one of these manager users has to go in and approve any certificate request before the certificate will actually be issued to the client. Again, this is default in ADCS. The third one is similar to manager approval, but in this case, it needs an existing certificate to sign the new certificate before it will be issued. So again, this is not enabled by default in ADCS. Moving on to the next one. So this is the actual security descriptor on the certificate template allows for users to enroll within it. And then lastly, the certificate template can be used for domain authentication. This is going to be those EKUs we saw before, where the certificate could be used for client authentication. So giving a more visual, this is an output from a tool we'll be discussing in a little bit. So at the top, we can see we have our CA. So this is Overwatch ADCS CA. And then that first prerequisite on the CA level is that authenticated users are allowed to enroll in certificate templates. Moving down to the certificate template level is where we're going to see the other requirements. So it's out of order in the output, but we can see here that 2 manager approvals disabled, 3 no authorized signatures required. We have enrollment rights for domain users, and the EKUs allow for client authentication. So our first privilege escalation and abuse case is ESC1. And ESC1 all revolves around low privilege users being able to specify that subject alternative name. So when templates allow for authentication, the certificate can be used for authentication to the domain as the enrollee and the subject alternative name. So when a user requests a certificate, they will be the subject, but if they can specify a subject alternative name, it will allow that user to specify any other user, and the certificate can be used to authenticate as that user as well. So ESC1 is where low privilege users can specify any domain user, including domain admins, within the CSR. So it seems like a pretty severe vulnerability, and you might be wondering how this happens in environments. So in ADCS, when you make a template, you can't actually make a template from scratch. It has to be duplicated from an existing base certificate on the CA server. And if that certificate has supply in request already on there, so we can see on the left here, we're copying the web server template, which already has supply in request, you don't get a warning saying that this could be abused. The only warning you will get is on the right. So we copy the default user template, which does not allow the user to specify the SAM, but if you turn it on, there's just one warning that says this certificate can use a subject alternative name and a security risk might be present. So if this is clicked through, either by someone who doesn't know the implications or just by accident, that's the only warning ADCS will give you. So doing an analysis on our output, here we have the template name, router, and role. So in addition to our prerequisites that we discussed earlier, you can see the field for enrollee supply subject. When this is set to true, any user who can enroll in this template can specify the subject alternative name within their CSR. So now we want to give you a quick demo, show you hands-on live what this looks like. So here we find ourselves in a Cobalt Strike session. So this is on an engagement. We get code execution on the computer, and we have Cobalt Strike running under a low priv user. In this domain, low priv has no special permissions. It is just a domain user. So here, to prove that we are just a domain user, we're going to use Mimikatz. We're going to give it the DC sync module and see if we can get the NT hash for the administrator. So Mimikatz gives us an error because we do not have sufficient privileges to perform that action. So the first thing we're going to do is we're going to use execute assembly and run the certify.exe binary from Will and Lee. We're going to give it the find module, and we're going to give it the vulnerable flag, so we only are getting vulnerable certificate templates. So here we can see the beginning and the output. We have the corp issuing CA. And the most important thing to note here is that full name. So that's going to be the corp issuing CA, and then the name of the CA server. And then when we go down to our certificate templates, we can see here we have one vulnerable one. And we're going to have that full name we saw from the CA. So we can see we have the RDP auth. The enrollee supply subject flag is present. We do not require manager approval or authorized signatures. And then we do allow for client authentication. And domain users are granted enrollment rights to the certificate. So this is all our prerequisites for ESC1. So again, we can run our certify exe binary, this time with the request module to request the certificate. And there's a few flags we need here. So that full name, the template name of RDP auth, and then for specify the subject alternative name, all we need to do is give it the alt name, and we're going to give it administrator, which is a DA within this environment. So we can see the certificate's been issued. The request ID is going to be 19, and it's important to note that later for revocation and cleanup. But as we can see here, the binary spits out a .pem file with all our RSA keys. So what we're going to do is we're going to copy this to a file, and then certify actually has a nice outputs where with OpenSSL, we're going to convert this to a full PFX certificate, and then we can use that for authentication. We're going to need to give it a secure password. And then we're going to base64 encode it so we can actually use it in memory with another tool called Rubius. So we're going to use execute assembly again. We're going to give the binary of rubius.exe. We're going to be using the ask_tgt module to request a TGT ticket for the user administrator that we requested the certificate for in a domain. We're going to pass the ticket into our session. We're going to get the credentials. So this will be get the NT hash for the user. And then the certificate is where we're going to paste that base64 encoded blob. So after a few seconds waiting for the beacon to call back, we can see that the TGT request was successful. And then if we scroll down, we can see that we imported the ticket into our session. So we've acquired the privileges of administrator. And then with the get credentials, we have the administrator NT hash. And then to prove we do have domain administrator privileges, we're once again going to run a DC sync with Mimikatz. And as we can see here, the command was successful, and we have successfully gained administrative control over the domain. So one thing we wanted to touch on here before we go further are what are the impacts of this? So a few things. We can be any user in the domain. We don't need an elevated context. And this is long-term persistence. So one thing we're going to get into is these certificates are valid until the expiration date, or they're explicitly revoked within the CA. So even if a password reset is performed on, say, that administrator user, the certificate is still valid for persistence. Right now, there's very few detections for ADCS abuses, at least currently. And those that do exist need to be put in manually and also require a manual analysis. And then lastly, we're not performing actions that are common of malware. So we're not touching critical processes like LSAS. We're not escalating our privileges on a host. So we're just abusing normal functionality of Active Directory. All right, so to show a little example of this persistence, we have a demo of this as well. So we find ourselves back here in the Cobalt Strike, and specifically we're looking at our output from Certify. So looking at our vulnerable certificate templates, we see the validity period for this one is going to be 2 years. So this means that unless a certificate expires or it's been explicitly revoked at the CA, that certificate will be valid for that full 2 years. So to demonstrate this, we're going to use the same certificate we had in the first example, and we're going to rerun this to get the TGT and the NTLM hash for the administrator user. Take note of what this hash looks like. Now we're going to go over to our DC, and we're going to change the password for that administrator user. Okay, password has been changed. So now we're not going to change anything. We're just going to use the same cert and once again request that TGT and get the NTLM hash. And as we can see here, the NTLM hash is changed with the password. So even though the password was changed, this certificate is still valid.
Okay, so the next ESC that we wanted to go over is what's known as ESC 6, and it's that mouthful of a name, edit F attribute subject alt name 2. So it's easier to say it's the just make it work setting. So in addition to what we discussed previously with the vulnerable prerequisites, ESC 6 is a misconfiguration at the CA level. So when Zach was discussing ESC 1, that was at the template. This one is a more global misconfiguration. So when this setting is enabled on the CA, it effectively makes any CSR able to specify that subject alternative name flag. So any template with a valid CSR can have an alternate subject name, and this is set even if it doesn't explicitly state that the subject alternative name is enabled. So a lot of questions come up about why this would actually be turned on, and a lot of it is just to just make it work. So you might have a system administrator that's trying to get things running on their CA, and they just may not understand exactly the implications of what they're doing. Additionally, this is actually recommended in some third-party documentation. So what we've got here is an example of some instruction to enable this setting. So you'll see the cert util flag here is our command is actually highlighted, and this is what's actually enabling that setting. So as soon as that's done, you stop the cert service and restart it, and now every single template that's allowed for, or excuse me, every single template that is allowed for client authentication can supply that arbitrary subject alternative name. And here we've got another example of what that looks like. It's just another set of documentation, essentially doing the same configuration. So looking at our output, this is from that tool certify that Zach had mentioned. At the CA level, we've got our CA name is Overwatch ADC SCA, but specifically what we're looking for is that user specified SAN. And when you see this set to enable, this certificate authority is vulnerable to ESC 6. So again, we want to do another quick demonstration of what that looks like. Okay, so we're going to jump back into Certify, which is the Python implementation of Will and Lee's tool Certify, written by Oliver Liak. So the first thing we want to do is run this the certify find command, which is similar to what certify had with the find vulnerable, and we're going to provide that low privilege user's credentials that we had compromised in the previous scenario, and then we're going to point authentication to our domain controller, which is at 10.10.100.8. And then by supplying the enabled flag and the text flag, we're only going to query for those templates that are enabled and available for enrollment, and we're just going to have the text file on the output. So you can see that it was able to enumerate that there are 36 certificate templates available in Active Directory. We've got the CA's name is the Corp issuing CA, but what's different here is that you only have 8 enabled certificate templates that are available for an enrollment. So if we take a look at that, we've kind of already taken a glance at this, but we wanted to compare it to what we would see with the output from Certify. The CA name is a little bit different. So the conventions for between the tools are a little bit different. We've got the Corp issuing CA. And then down here we can see that the user specified SAN, which is the ESC 6 privilege escalation, is set to enabled on this CA. And now to demonstrate how this can impact certificate templates that don't have that enrollee supply subject flag set to true, we're going to choose to use the default user template. So this is enabled by default on CAs when it's deployed. You can see that it's enabled true. It does support client authentication. However, the enrollee supply subject flag is actually set to false. And then you can see that domain users, again, a default setting, have the enrollment rights on this template. To abuse this, we're going to go back to our certify, and then we're going to swap out the find module with the request module. And again, we're going to be using that same low privilege user credentials. This time we're going to point it at the CA since we're actually performing a request. And then the flags that we're going to provide it are the CA name, the specific template that we want to abuse, which is that user template, and we're going to supply the alternate name as administrator. So you can see the output from the tool. It says that the request was successful. We got a request ID is 23, and then the alternate name is set to administrator. And the tool actually output a usable PFX file that we can use for authentication over PKInit. So we'll swap out the module from the request to auth, and we're going to authenticate as that administrator user. We're going to supply it the administrator PFX file that we just acquired, and we're going to go back to the domain controller IP this time at 100.8, and our domain is corp.local. And after a brief delay, we're going to get the ticket granting ticket for that account. All right, so you can see that we were successful in acquiring the ticket, and it saves the credential file in a Ccache format, which is usable with other tools. And specifically, what we wanted to see is that we would get the NT hash for the domain administrator account. And to demonstrate, similar to what we did with ESC1, that we do have the privileges of the administrator user, we're going to do secrets dump, which is essentially a DC sync. And we're going to specifically request the credentials for the low privilege account that we've compromised. And as you can see here, we were able to pull those hashes down, which validates that we have escalated privileges within this domain.
So moving on to our third ESC, this is ESC 8, and this all has to do with the web enrollment functionality of ADCS. So ADCS supports options for a self-service HTTP portal. So this is a portal where users could go to and actually request and manage certificates all from their web browser. So by default, when it is not hardened, it accepts NTLM authentication. So in a situation of NTLM relaying, where you can intercept a user's NTLM auth and relay it to the CA, you can actually enroll in certificates as a victim account. So this can be combined with coercion methods such as printer bug, or more recently, petit patam. So when we're looking at our certificate authority, what we're looking for here, where we're looking for user specified SAN for ESC 6, we're going to be looking for the web enrollment being enabled. And then just to show you what it looks like when you go to the server. So this is the address of a CA, and on that cert serve address, you can see that you can do various tasks. So this includes requesting a certificate, looking at the status of a pending certificate, or even download a certificate. Okay, now to demonstrate ESC 8, we have another demo. So for ESC 8, we're going to come back to our certify output. And then again, we're going to be looking at the CA level this time again. So looking at the CA for ESC 6, we were looking for user specified SAN, but for ESC 8, we're going to be specifically looking at this web enrollment. Here we can see it is enabled, indicating it is running web enrollment on the service and is likely vulnerable to NTLM auth. So here on the right, we have NTLM relay listening, and we're pointing it at our CA server at that cert serve cert FNSH address. We're going to give it the flags for ADCS, indicating we want to request a certificate from the service. And then we're going to specify the machine template, which is default, and any domain computer can enroll in it. So on our left, we're going to run a petit patam attack, and coerce a workstation in our domain to authenticate to our host, where we then relay it to the ADCS server. Okay, so we can see that the attack worked. We see the incoming connection on the right, a CSR generated, and then we will get the output of a certificate in a second. Here, so it's going to do a base 64 encoded blob. And we can see we got the certificate ID of 33. So we're going to copy this whole base 64 blob. And then we're going to write it to a file so we can base 64 decode it. And then when we decode it, we can actually decode it straight to that PFX file that we can use with CertiPy. And then once again, we're going to use the auth module of CertiPy, this time specifying that machine account of PC01. We're going to use that cert we got from NTL and RelayX. And then we're going to use our usual flags of domain and DCIP. So as we can see here, TGT was successful, and we get the NT hash for the user PC01. And then just to prove that we do have control over this account, we're going to use that NT hash to authenticate to SMB. And we can see that the authentication was successful, indicating we do have control of that account. So we wanted to express here that if you don't have ESC1, you're really only limited by your own creativity. You can actually start chaining some of these ESCs together and create more complex attack paths. So for an example of this, we're going to go back into our CertiPy output, and we're going to pretend that we don't have that RDP auth certificate with ESC1. So when we're coming here, we see the certificate template name for router enrollment. So this certificate may not look vulnerable on its own. We see it's enabled and we see it has client authentication. We do see that the enrollee supply subject flag is false. We do see it doesn't require manager approval or authorized signatures, but when we come down to enrollment rights, we see that there's no domain users. We only have the domain computers. So at face value, this template may not look vulnerable. But remember, with our ESC8 and the machine account we just coerced to us, we have control of the domain computer. So what we're going to do is we're going to request with that PC01 user. We're going to request it from that CA. We can see the template is route enrollment. We're going to give it the alt name of administrator because remember with ESC6, even though it's disabled, it's overrode at the CA level. And then we're going to use that NT hash that we got from ESC8. So as we can see here, we have a successful request ID and we have a PFX for the administrator user. So just to show this works again, we're going to use the auth module for CertiPy. We're going to give it that newly PFX we acquired for the administrator and authenticate to the DC. So as we can see here, we successfully got the TGT again and the NT hash. So even though we didn't have ESC1, we were able to combine ESC8 with ESC6 to still get that domain administrator privileges.
Okay, so one thing we really wanted to focus on is the options for mitigations, because clearly what we've demonstrated is there's several ways to escalate privileges in the domain. So we wanted to show ways to get this fixed. So when focusing in on ESC1, it kind of goes from a path of least resistance to and then staggering down from that. So the biggest issue with the ESC1 was that any user could supply that enrollee supply subject flag. So if you can, ideally you would disable that setting on the certificate template itself. However, there may be a reason that was actually set to true. So you have to consider that when you're turning it off. Does it actually have to be enabled? And if it does, you still got options. So if it's a template that isn't used for authentication, you could just remove the authentication EKU. If it has to have the enrollee supply subject flag, has to be used for client authentication, then you can use the manager approval setting. So if this is enabled on the template, what that's going to do is actually put each certificate signing request in a pending state. So you'll be able to submit the request, but you won't actually retrieve a certificate until whoever has that manager role, until they actually approve it. So it kind of is a stopgap. Um, if that isn't something that you want to deploy, the next option is to use authorized signatures. And if you have enrollment agents configured in your environment, you can actually use those to perform, requests on behalf of users. Um, and then at the very biggest level is that you just would remove that low privilege user group from the template enrollment privilege, and you would really like dial in on the specific users that should have access to enroll on this object. So removing the domain computers, removing the domain users, and perhaps setting a specific security group with members of who should be able to enroll. Looking at ESC6, that's that global setting, which essentially makes every template vulnerable to ESC1 by allowing you to supply that arbitrary name. Um, Ideally, we'd have you remove that editf attribute subject alt name 2 registry flag on the CA. But as we demonstrated kind of going over it, this is recommended by third-party providers. So there's a reason, that this was set to enable. So we don't necessarily want to say go ahead and go turn this off because it might have an impact on your existing infrastructure. This is kind of a situation where if you were told to turn it on by a third party, you should reach out to that third party vendor to ensure that disabling that isn't going to cause any kind of downtime. Um, Again, so if it has to remain, if it actually has to stay to true, you would want to set it to enable and manager approval on all templates. That way, any template essentially would have to be reviewed by someone, and then they would actually have to go in and approve that before the certificate's issued. Because remember, this applies to all templates, so it's kind of a global setting. At the manager approval, again, if that's not something that's supported in your environment, you have the option to use the enrollment agents. But then again, we come back to remove that low privilege user access. You really want to focus in on the specific users, specific groups who should have enrollment rights over on that template. For ESC8, the best remediation is if that enrollment or the web enrollment endpoint is not being used, just remove it completely, disable it, uninstall it. That feature isn't necessary to actually keep running your PKA, your public key infrastructure. If it is something that's in use, you can actually harden it. So you could enable what's called extended protection for authentications. So that would mitigate the NTLM relay vulnerabilities, and then you would actually enforce authentication over HTTPS rather than the default setting of over HTTP. So it's not all focused on the offensive side. Will and Lee actually did create a tool that was on the blue side, so on the defender side, and that's a tool called PSPKI Audit, and it's a PowerShell based tool for auditing these misconfigurations that isn't malicious. There isn't any kind of abuse case with this tool. So what it does is it actually identifies the same misconfigurations that Certify or other similar tools will find, and it'll output that data so that defenders can go in and get these things remediated. Another cool feature is that you actually have the option to kind of audit your existing issued certificates to see if any of them have that a subject alternative name, and be able to look and see if there's anything that stands out that shouldn't have existed in there. So I wanted to take some time to kind of show you what that output looks like. So here we're connected to our domain controller, and we've already ran the output of PSPKI Audit. And you, at first glance, the output is very similar to what you get from Certify. You've got the computer name, the CA name, the full name of it. It's a little bit different on this one. Instead of like user specified SAN, it says allows user supplied SAN set to true. And then it'll actually show you the URL for the enrollment agent endpoint, or excuse me, the enrollment endpoint. And then it'll show you the misconfigurations at the CA level. So we've already shown you that it's vulnerable to ESC6 and ESC8. And then it'll pivot from there, and it'll show you certificate templates that are vulnerable. So here we had the RDP auth, client authentication, enrollee supply subject set to true, and this specific misconfiguration is ESC1. So in cases where ESC6 is present, the tool will actually identify which templates are vulnerable to ESC6. So it'll show you all the templates that are allowed for client authentication, and then the names of them that which can actually be abused by ESC6. So again, there's a default user template, and to demonstrate how you can audit the environment uh, by using the get cert request module, you can actually query for those that have a subject alternative name. And when that data comes back, you can see from our demonstrations the three malicious certificates that we enrolled in are present. So the low privileged user supply the administrator as an arbitrary name, PCL1 again administrator, and then low priv again as the administrator. So we wanted to take the time to acknowledge the researchers that kind of inspired all of this, specifically Will Schroeder and Lee Christensen over at SpectreOps. Their white paper certified pre-owned, and the corresponding blog posts are really what kind of caused this whole investment into researching this topic. And then Oliver Liak, they are the developer of the tool that we used or excuse me, they're the developer of Certify, which was the Python implementation of Certify. And then Lionel Gallet, sorry if I butchered that. Uh, they are the developer of Petit Batam, which we used in the demonstration for ESC 8. So we've got some references, specifically that white paper that I just mentioned. That is a wealth of knowledge, and then we only cover 3 out of the 8 ESCs that Lee and Will highlight in there. It's got abuse cases, it's got remediation cases. It's absolutely check that out. If you're curious about Certify or Petit Batam, you can grab those on GitHub. And then the PSPKI Audit tool that we mentioned for the remediation, the blue side of things, that's available on GitHub as well. So that was the talk. Thank you so much for watching. I know that Zach and myself will be in Discord after the talk if you guys have any questions. Thanks.